The topic of encryption is included in the objectives on this 70-43 exam, so you need to be familiar with it, but keep in mind that encryption and cryptography and security is a big topic. I'm going to kind of give you some pointers here in the next few videos, and we're going to talk about symmetric and asymmetric encryption, and we're going to talk about some hashing data, and then I'm going to show you some code examples on hashing and encrypting, and then we'll get into some assemblies and stuff. But I'm going to show you some things to kind of get you started, and you'll have to do a little bit of digging and reading here to actually get prepared for this exam. But let's start off with the basics. Now, there are two main types of encryption that you can use to protect data, and that is symmetric encryption or asymmetric encryption. Make sure you know the difference between these on the exam. Symmetric encryption is also called shared key encryption. Now, the same key is used to encrypt the data that is used to decrypt the data. So, this is going to rely on the fact that only authorized people have access to the encryption key. This is much like your house key. Everybody who has that key can get in. They can lock the door and they can unlock the door, and it's not good for too many people to have those keys. Now, .NET employs a chaining mode called the Cipher block chaining method for symmetric encryption. Now, why do you need to know this? Because when you start coding it up, you're going to notice a couple of things. First of all, what's happening here with this cipher block chaining is if the data that's being encrypted is larger than a certain size, which is called the block size, that data is then split into blocks of whatever that predefined size is. If you're familiar with TCP/IP, it's also the same type way that we break our data up into packets. Same type things happening here. Now, the first block of data is encrypted using two things. A random block of data of the same size, and this is called the initialization vector, the IV. You will see the IV, the initialization vector, mentioned in the code that you're going to have to write to do encryption. You'll see it in some sample code later on in the course. And then it'll also use the encryption key. Now, the next block, if there's more than one block, is encrypted using the result of the previously encrypted block instead of the IV, along with the same encryption key. So the initialization vector is only used on the first block, and everything else is used based on the last block along with the encryption key. And this process just continues kind of leapfrogging through all the blocks until the last block is encrypted. Now, if that last block is smaller than the standard block size, it gets padded with data. And I think in our example, we're going to pad it with zeros or something like that. So that's symmetric encryption. The main characteristic there, just remember that initialization vector, you'll see that in the code. That's what's going on there. But with symmetric, you're basically sharing the same key, and one key encrypts and decrypts the data. Now, to decrypt the data in symmetric encryption, you must have the IV, the initialization vector, and the encryption key to do that. Now, with asymmetric encryption, it utilizes two keys, a public key and a private key. Now, these things are like mathematical opposites. If I encrypt the data with one of these keys, I'll have to have the other to decrypt it. Now think about this. This is the same as if I had two keys for my house. One key will lock the door and the other key will unlock the door. All right, so same type thing here. Now, one of the keys gets shared publicly and the other one is kept private and guarded. Now, asymmetric encryption is slower and more complex to implement than symmetric, and so you want to use it in higher security situations where the less efficient, more time-consuming method is worth it based on the security that it provides, whatever your data is. It's usually used to encrypt a shared key that is securely delivered to both parties, and then the shared key is used to provide symmetric encryption between the parties. And so we're basically using, for example, like in secure socket layer encryption out on the net, we're basically using asymmetric to pass that shared key, and then we're doing symmetric because it's so much faster and easier. But since we've used the public and private key to encrypt the shared key, we now know that only people we trust have the shared key. All right, so that's the main difference between symmetric and asymmetric encryption. Just make sure symmetric uses the shared key, asymmetric is public-private, and that's a good place to start for understanding cryptography, especially in the .NET framework.